Cross-laminated timber, CLT. Just how sustainable is it? CLT has been touted as one of the most important evolutions in building materials in the 21st century, but not much has been said about the potential downsides. A paper came out in Nature Communications in 2025, and it deserves a much deeper look because it taps into exactly the things that haven't been said about the mass timber industry. So today, that's what we're doing, unpacking the world of CLT and its potential for causing deforestation. Welcome to Source Material. I'm Alicia Callahan, the founder of About Futures. I'm a former magazine editor with an honours degree in interior design. So here's a story we've been told about mass timber. For about a decade now, it's been positioned as one of the defining answers to decarbonising buildings. Cross-laminated timber, glulam, these engineered wood products, they carry the kind of structural loads that we have typically seen in things like concrete and steel. And no doubt you've seen the headlines. Every year it seems like the tallest timber building in the world gets just that little bit taller, and every year the argument gets louder. Wood stores carbon, forests grow back, and if we build with timber at scale, we can shift the whole construction sector from being a net emitter to something closer to a carbon sink. It's a compelling pitch. And, it is true. The question that this paper asks, though, is what happens when we actually do it? Not just a couple of buildings here or there, but at scale, globally, for the next 75 years. This is an entirely different question. And the answer that this paper outlines might come as a surprise. Okay, so let's have a look at it. It's called Global Land and Carbon Consequences of Mass Timber Products. Lead author Kai Lan, with co-authors from Yale, the USDA Forest Service, and a few other institutions. It was published in Nature Communications in May 2025. It's open access and the link is below. So here's what this paper does differently. Most mass timber life cycle studies, and trust me, there are a lot of them, they look at just one building or one supply chain. They run the numbers on a single project and ask, is this timber tower lower carbon than the concrete equivalent? Usually the answer is yes, and that's pretty useful. But it's not the question we need to answer if we're thinking about the whole system. And so this paper combines two tools: a life cycle assessment, which is, the standard carbon accounting measure for the material, tracing it from the forest to the end of life. The second thing that this paper does is it models the Global Timber Model, GTM for short, which is an economic model of how the global timber market responds when demand changes. So it's this combination that makes for an interesting assessment. Most studies assume that when it comes to a forest, that there's this supply of sustainable wood just sitting somewhere ready to be used. The GTM doesn't assume that. It models what the market actually does. So which forests get planted, when they're harvested, and which ones get left alone. And so all of this then means that they can control the price of wood, kind of like oil, or if you've ever looked into the maple syrup supply, it's controlled as a way to control the price. And so it turns out that that matters a lot. So what does the paper actually find? The authors model 3 scenarios: low, medium, and high adoption of cross-laminated timber globally, running from 2020 to 2100. And this is compared against a baseline where CLT adoption just, doesn't really take off. So in the high scenario, where CLT replaces concrete or steel in approximately 60% of new urban, mid, and high-rise buildings, the numbers are genuinely striking. So life cycle greenhouse gas reductions of up to 39 gigatons of CO2 as a reference point, because I can't even fathom that. That's roughly 1 full year of our current global energy-related emissions just avoided or stored simply by switching the materials that we build with. It also means that forest area expands by up to 36.5 million hectares. So that's about the size of Germany, just added to the world's productive forests by 2100. So the calculations also say that long-term carbon storage will go up 20 to 25 gigatons, partly because of the buildings themselves, like the carbon that gets locked into every wall of a CLT tower, but also in the forests that grow to supply them. So if you just read the abstract, this is where you might stop. And, these are real numbers, so fair enough. It's a serious journal, and the carbon benefits of mass timber at scale are not invented. It's not greenwashing, but the paper doesn't stop there. So neither should we. Here's the part that might get missed if you were to just do a quick skim. So the expansion of these forests, it doesn't happen uniformly. It happens in really specific places. So, the United States, Western Europe, China, Canada, all of these countries, they have already established plantation forestry and well-developed timber industries. So in these places, rising timber prices driven by all this new demand for CLT means more plantations get planted. So more land shifts from small farmland into managed forests, and forestry will get more intensive, faster growing species, shorter rotations so that you can have higher yields. And the model predicts something else as well. In tropical regions, so near the equator, places like the Amazon, Borneo, Ecuador, just the lushest of the luscious natural habitats, the same market pressures will work differently here. And it outlines the fact that natural forests are predicted to decline. And the authors are direct about this. They write, and I quote, "There is a trade-off between conservation and carbon goals." Read that sentence again, because it's the one that really hits home when you stop and think about it. In places where forestry control is weaker and land is cheaper, which is of course often in tropical regions, the timber needed for CLT will be coming from native natural forests that already exist. A monoculture pine plantation stores carbon, sure, but a monoculture pine plantation is not, in the way most of us mean the word. A forest, it doesn't shelter biodiversity or support a soil ecology. It doesn't do the other things that a living forest does, like regulate water, habitation for species, or carry the history of a place. It's considered an agricultural crop. It just happens to be made of trees instead of wheat. So when someone tells you that building with mass timber means we plant more trees, and that must be a great thing, it is true, and it matters enormously. But it also matters which trees, where. What do we do with all of this? So the paper is not saying that mass timber is inherently bad. It's clearly not saying that. The net picture is positive, especially if we compare it to, say, concrete and steel. If you take nothing else from this video, take that. But what it is saying is more specific. And that kind of makes it more useful, right? Mass timber at scale is a policy problem, not a material problem. The carbon benefits are real, but they're also contingent because they depend on where the wood comes from. Is it replacing virgin forest for monoculture pine? How is the market regulated in the country of origin? How does the land tenure work there? And how are logging concessions granted? And to be clear, it is possible to have locally managed plantation, which doesn't destroy virgin forests and which also employs the local community to look after it so that all of the profits are fed back into maintaining and keeping that community going. It also means that CLT and mass timbers as a material are only as sustainable as the supply chain attached to it. So a note on what this paper doesn't do. The economic model assumes it will take place in a functioning market with reasonable enforcement. So in parts of the world where illegal logging is already a problem, that assumption is a bit generous. This paper also doesn't look at adhesives. The glues that hold CLT panels together have their own story. They're petrochemical based, they're full of formaldehyde, and it complicates the end of life process. But that is a whole conversation of its own that we will get into in another episode. This paper also can't predict unforeseen circumstances. So if we have climate-driven dieback or bushfires, pest outbreaks, changes in policy, none of that is accounted for. The model runs a scenario where the next 75 years behave more or less like the ones that we've just had in the last few decades. And we know that assumptions are getting shakier every year. Things are pretty unpredictable at the moment. If anything, this paper shows that there just really is no perfectly sustainable material. There's only the right compromise for the right situation. And mass timber can be a very good answer when it's used for the right kind of building, when the supply chain is checked and, it's thought all the way through. This paper is useful because it refuses to give us a simple answer. And that's the kind of honesty that sustainability as a whole conversation just needs way more of. The full paper is linked below. If you found this useful, I write about topics like this at About Futures. You can sign up for our free newsletter. The link is below. And for the next episode, the glue question. See you then.